Hi math students, it's Mr. Hajgassam, and today we're going to learn how to change the subject of a formula. Now, just starting with a joke here, we've got students saying, change the subject, yes please, I would love more maths. Now by subject, we don't actually mean, a subject that you study. Subject in this case is the variable that we are trying to find. So in this case, this is actually the Pythagoras formula. So Pythagoras formula is a squared plus b squared equals c squared. Now, if we rearrange this to make c the subject, this is what our formula would look like. So it's essentially taking the square root of a squared plus b squared. So c equals square root of a squared plus b squared, which is what we have over here. So when changing the subject of a formula, we have to rearrange the formula so that we have a different subject. And we will see how this works in this lesson. So moving on to the next slide, here's a worded example. So the question says the cooking time for roasting a nut roast is calculated using the following formula, which links the mass of the nut roast to the cooking time, where T is the time in minutes and M is the mass. So the time is equal to 50 times the mass plus 25. Now, if the nut roast took 70 minutes to cook, how much did it weigh? So now, based on this formula, we have the time. So we're going to substitute 70 into this formula here. So instead of T, we're going to write 70 is equal to 50m plus 25. So we need to rearrange this formula to find the value of m, or to find the mass of the nut roast. So we have to make m the subject here. Now, if you're good at solving equations, this would be quite straightforward. So because we're adding 25, we have to subtract 25 from both sides to get rid of this 25, because we want to isolate m. We want to have m on its own. So 70 minus 25 is going to be 45. So 45 is equal to 50m. And now what we have to do is divide both sides by 50. And the reason why we're doing that is because m is being multiplied by 50. So to do the inverse operation, we would have to divide both sides by 50. So 50 divided by 50 is equal to 1. So we'll end up with 1m. And rather than writing 1m, we will simply just write m. And then 45 over 50 is going to be equal to, if we divide both sides by 5, 9 over 10. So m is equal to 9 over 10, and 9 over 10 is equal to 0.9. So m is equal to 0.9 kg. That was the mass of the nut roast. So by simply rearranging the formula, making m the subject, we can find the mass. Right, moving on. So let's have a look at these questions here. It says make x the subject of the formula. So again, we want to get x on its own. Now, over here, x is the denominator of this fraction. So we want to get rid of denominators. When we usually have denominators or fractions, life becomes a little bit more tricky. So ideally get rid of the fraction first. So because we're dividing 3c by x, we have to multiply both sides by x to get rid of this fraction. So x and x cancel out. What we'll end up with is 3c is equal to 2bx, because 2b is being multiplied by x. Now we can isolate x. We can get x on its own. And to do that, we want to get rid of this multiplication by, because this is the same as 3c is equal to 2b times x. So to get rid of this multiplication by 2b, we have to divide both sides by 2b. So 2b divided by 2b is simply 1, so they cancel out. So x is equal to 3c divided by 2b. We can write that as a fraction now, 3c over 2b. Remember, division is always it can be written as a fraction, because a fraction is essentially a division problem. So we've made x the subject. X is equal to 3c over 2b, or we can write it like this. It doesn't really matter which way around you write your equation. All right, another example here. So this one's slightly trickier, but again, what we can do is get rid of this subtraction of g. And the reason why we start by getting rid of this subtraction is because if we think about BIDMAS, this is the order of operations. So BIDMAS is the order of operations, brackets, indices, division, multiplication, addition, and subtraction. So we follow this order when we are doing an operation. But when we are isolating a variable, in this case x, when we are isolating x, what we want to do is undo the operations that are happening to x. So in this case, x is being multiplied by a plus b, and x is also, we are taking g away from x. So to undo the operations, we have to follow the opposite order. It's almost like putting your shoes on and your socks on. You put your shoes on first, sorry, you put your socks on first and then your shoes on. But when you're taking them off, you would have to take your shoes off first and then your socks. So likewise here, when we're taking off the operations, we have to follow the opposite direction of BIDMAS. So we'll start by getting rid of the subtraction. So to get rid of minus g, we have to add g to both sides. So this is going to become a plus b in brackets multiplied by x is equal to y minus g. Now what we're doing to x, we're multiplying x by a plus b. So we simply need to divide both sides by a plus b in brackets. So x is equal to y minus g divided by a plus b. And we've made x the subject of our formula here, or the subject of this equation here. All right, and moving on to more difficult examples. So here we have an indice that can make life a bit more trickier, but let's start again. This time we want to get rid of this y. We're multiplying x plus b by y, so we can get rid of this y first. So what we'll end up with is x squared plus b is equal to g over y, because we have to divide both sides by y. And now we are adding b to x squared, so we would have to subtract b from both sides to get rid of this addition of b. So x squared is equal to g over y minus b. Now, because we are squaring x, what's the opposite of squaring? Well, the opposite of squaring is square rooting. So we would have to take the square root of both sides. So this and this will cancel out. Therefore, x is equal to plus minus g over y minus b. And that would be our answer. So you have to be very good at rearranging equations and understanding inverse operations when you are rearranging. So here, the inverse of adding b is subtracting b. The inverse of squaring is square rooting. The inverse of multiplying by y is dividing by y. So you have to be very good at your rearranging and inverse operations. Right, and moving on. So here we have a slightly more trickier example in the sense that the variable that we want to make the subject, in this case a, is on both sides of the equation. So what we will have to do here is to get the variable that we want to make the subject on one side of the equation. So over here, what I'm going to do is subtract at from both sides. So I'm going to subtract at from here. So at minus at is 0, so they cancel out. What we'll be left with is a minus at on this side is equal to u. Now, it's a little bit tricky. You might be tempted to say, well, a minus a is equal to u over t, but bearing in mind, this is one term in itself. This is one term in itself, so we can't leave the a here and divide both sides by t. That would be incorrect. So this is wrong. What we will have to do, this would be right, just before I move on, actually, this would be right if you had written A is equal to U minus AT. This would be correct, but again, it's no good because it's not going to work because A is still on both sides of the equation. So we'll skip that for now, as it wouldn't really help us. What we would have to do is to factor out A. So we have to factorize this expression over here on the left-hand side of the equation. So to do that, we want to find the highest common factor of the two terms. So the highest common factor is going to be A, because A is in both of these terms. A goes into A and A also goes into AT. So A goes on the outside, and then you have to ask yourself, A times a number or a variable to give us A. Well, that's going to be 1, because 1 times A is simply A. And then A times a number or a letter to give us AT. Well, that's going to be and in fact, sorry, before I move on, I've made a big, huge mistake, which I'm going to rectify. I realized we can't actually divide U by AT. So if we did A is equal to U over minus AT, that would be wrong as well, because what we're actually doing here, we are subtracting AT from A. So to get rid of this subtraction of AT, we would have to add AT to both sides. So I do apologize. I did make a mistake earlier. So what this would end up looking like if we were to get rid of this AT would be A is equal to U plus AT, but that takes us back to our starting point. So it's not going to help. So excuse my earlier error, please. But going back to what we were saying, so we'd have to factorize this expression here. So that would be A in brackets 1 minus t. A times 1 is A times minus t is minus AT. So that's factorized is equal to U. Now that we've done this, what we're saying is A times in brackets 1 minus t. So because we are multiplying A by 1 minus t, we can divide both sides by 1 minus t to isolate A. So what that becomes is A is equal to U over 1 minus t. And this is our final answer. So the tricky part here is that we have to factorize this expression here and bring all the A terms to one side. Here's another example. So again, we've got G is equal to P plus GF. Once again, we have to bring the variable that we want to make the subject on one side of the equation. So this is going to be G minus GF is equal to P. Now again, we would factorize. So G is the highest common factor of the two terms. So G will go on the outside. Then we will get 1 minus F is equal to P. Just to double check, G times 1 is G. G times F is minus GF. So if we were to expand this, we would get our original expression. So this has been factorized correctly. Now what we need to do is divide both sides by 1 minus F. So divide both sides by 1 minus F. So what we'll end up with is G is equal to P over 1 minus F. And now G is the subject of our formula or of our equation, as the question says, change the subject of the equation. All right, and moving on. So here we go, make M the subject. Now I mentioned earlier when we have a fraction, when we're dealing with a denominator, we want to get rid of this denominator first. So what I'm going to do is multiply both sides by 2 to get rid of this. So these two cancel out. What we'll end up with is 3M minus 2 is equal to 2 times AM plus b. Every term on this side has to be multiplied by 2. Now, what we can do is bring this over onto this side of the equation. So we'll divide both sides by 2 am plus b. So 2 is equal to 3m minus 2 over am plus b. But again, life has become a little bit tricky here because we're dealing with a fraction again. So rather than doing it like this, what I will do is expand this expression here. So rather than doing this, I'm going to expand. So 3m minus 2 is equal to 2 times am, which is 2am, and then 2 times b, which is plus 2b. Now what we need to do is rearrange the equation so that we have the m's on one side. So I'm going to subtract 2am from this side, so these two will cancel out. So what we'll have is 3m minus 2am minus 2, don't forget to bring down this minus 2, is equal to 2b. Now I'm going to get rid of this minus 2, so I'd have to add 2 to both sides. So what we'll end up with is 3m minus 2am is equal to 2b plus 2. Now I'm just going to continue on here. So 3m minus 2am plus 2. Whoops, sorry, that is wrong. 3m minus 2am is equal to 2b plus 2. Now, the next step here, we have the m's on one side. So again, we would have to factorize. Now, the highest common factor of these two terms is simply going to be m. So we take m out, 3 inside the bracket, minus 2a. M times 3 is 3m. M times 2a is going to be minus 2am. So this has been factorized correctly, is equal to 2b plus 2. Now, as we're multiplying m by this bracket here, we would have to divide both sides by 3 minus 2a. So what we'll end up with is m is equal to 2b plus 2 divided by 3 minus 2a. And m is now the subject of our formula. So this looks a bit longer than what it should be, but that's because I've taken quite a lot of steps, especially showing what I've done when rearranging. But if you're very confident with rearranging, you can get to this stage very quickly, and you can actually skip out these two steps. Okay, so let's do another example. So it says make A the subject. Now again, A is the denominator, so we want to get rid of A on this side of the equation. We want to get rid of the fraction, so multiply both sides by A. What we'll end up with is A plus 1 is equal to AY. Now we want to have all the A's on one side, so 1 is equal to AY minus A. I want to get rid of this A here. So I'm going to subtract A from both sides. So 1 is equal to, now we have to factorize this expression here. So A goes on the outside, Y minus 1. So A is equal to 1 over Y minus 1. And maybe I can write that a bit neater here. So A is equal to 1 minus over Y minus 1, and that's our final answer. Notice that I'm multiplying A by the terms in the bracket, so I would have to divide both sides by Y minus 1 to get rid of this. All right, let's do another example. Now make X the subject here. So in this case, what I have is x plus 3 as the denominator. So again, I have to multiply both sides by x plus 3. So what I'll end up with is 2x is equal to y multiplied by x plus 3. Now, once again, expand the bracket. So 2x is equal to xy plus 3y. And then what we will get is, so move the x's to one side because we want to make x the subject. So we want to get rid of this. So we would have to subtract xy from both sides. So 2x minus xy is equal to 3y. Now we can factorize. So take out x, that's the highest common factor. So this becomes 2 minus y is equal to 3y. And then what we will have to do is divide both sides by 2 minus y. So x is equal to 3y over 2 minus y. And that will be our final answer. So x is now the subject of our formula. Right, boys and girls, I hope you found this useful. Remember, when we are rearranging, we have to follow the same rules as solving equations. So follow what you know about inverse operations to rearrange your equations. And then look at what the question's asking you. What do we want to make the subject? Now, where you have the subject on both sides of the equation, you have to make sure you bring them to one side of the equation, and then you can factor out the subject. So that would leave you with only one subject, and then you can follow your rearranging process as we have done here. I hope you found this useful and have a nice day. Bye.